Good morning. I'm Pat Balakrishnan. I manage the platform software and cloud integration at Violin Memory. I'm going to go over some of the ease of use and supportability and serviceability features. Before I get started, let me answer one of the questions that came on Twitter feed. The question is why FSB 7700 has an internal FC switch. So the answer is, a 7700 does not have an internal FC switch. The connection between 7700 and 7300, 7600 is through an external FC switch. So let it be clear.
So Jay Metz was wrong.
Yeah, I think there's a misunderstanding in that. When we introduced the FSB platform a while ago, the biggest challenge we had was a lot of complaint from the field that it takes time to install and configure the system. So we wanted to make it so easy that even a 10-year-old should be able to install the system. So let's see how it works. It's a registered name is simple setup. It's supposed to do complete auto configuration of the system from start to end. We have a web interface. It's a tool available in our support site. Before the system arrives in your data center, you collect all the data of IP addresses, all the configuration information. Go to our website, punch in all the details, and it'll generate a config file with the chassis serial number. You copy the config file and into a USB stick and keep it ready. As soon as the system comes, you power on the chassis, connect all the cables, of course. Power on the chassis. As soon as the system boots, insert the USB stick into the master array control module. The array control module reads the configuration file, configures all the IP addresses of the array control module and the MGs, does the media initialization, and starts communicating with the Symphony server that is in the same data center. Also, we take the email address of the installation engineer, and the progress is reported via email during the entire process. So once the Symphony server detects the new array, all you need to do is just pull in the new array and create LUNs and start using the system. It's as simple as that.
What information is actually coming from the USB stick then?
All the IP addresses, call home information, installation information, and how do you want to configure the LUNs. So basic information of entire system is coming from the config file.
Would you be able to set this up in like a centralized server build?
Sorry, what's the question?
Given that you have this tool and you're putting it on a USB stick,
yeah.
Why wouldn't I be able to use something just like, I've got a centralized config server sitting in the network somewhere, and as soon as a new thing comes in, it goes to the server.
So that would be the next step.
That's the next
right?
step. Okay.
Since we have a Symphony server running in the same data center,
Yep.
it should be able to do auto detection.
Yes.
Yeah.
Yep.
So how long the installation engineer actually spends time in front of the system? It's exactly 44 seconds, right? After that, he's allowed to remove the USB stick and move on to the next system. The rest of the system configuration happens in the time frame of 30 minutes, and he doesn't need to be standing next to the system. And the progress is reported through email to his personal email ID, so he can check that from anywhere. So system is ready under 30 minutes.
So what kind of tasks are being done from 1 minute to 30 minutes? What kind of configuration?
Okay, so the array control module has its own IP address and call home information that gets configured. The next, the gateways are configured, the IP address and everything configured and rebooted. Then the media gets initialized. Okay. And the next step is to contact the Symphony server that is running in the same data center, and call home information sent out, email sent out, and we are pretty much done.
Can I just make an observation?
Sure.
And look at when people say it only took us a minute, it only took 30 seconds. And I always think that's pretty irrelevant when it takes a certain amount of time to turn up to somewhere, sign in, unpack the box, physically get it in the right place, and all those other things that go on around this, so that the 1 minute to configure is an irrelevant measure. However, so that aside, actually this is more about making sure you don't make mistakes.
Correct.
That it's all about, when somebody plugs it in, they're not getting it all wrong, misconfiguring. And I think you should focus more on the benefit of that side of it rather than worrying about that it only takes a minute to actually bring the thing up.
Yeah, that's a good feedback. So the biggest challenge that many of the installation engineers complained about is that they had to hold on to a laptop, connect to a serial port in a crowded data center, and punch in a whole bunch of data.
Exactly.
So that's what we are removing from this.
The ways to make mistakes.
Correct.
When you're sitting doing that. So I think this is a great way to do it, to stop the mistakes being made, but it doesn't necessarily make a lot of sense to say it only takes a minute to complete.
Yeah, correct. It's more of a configuration help than installation help.
Absolutely.
Correct.
Is it customer installation, or is this a Violin engineer that would be doing this process?
Customer can do it as well.
Okay.
Yeah. It is so easy that anybody should be able to do it. Also, it's still there's a possibility that you may punch in some wrong information in the config file. The system may not get configured. So in that case, we write a log file back into the USB stick. So you will be, if the system is still not configured, you can inspect the log file from the USB stick and correct your mistake. Okay. So we also support non-disruptive upgrade, and it is with traffic running, data services completely running and available. And let's see how it works. These are the components in the array. The blue represents the current version, and the pink represents the next version. First, we upgrade the standby array control module. Then the master array control module gets upgraded. And these are all completely not in the data path. And RAID control modules, all the VIMs are moved to the next VCM, and the single VCM gets upgraded. All the VIMs move to the other VCM in the same group. One by one, all the 4 VCMs gets upgraded. Once all the VCM, the RAID controllers are upgraded, now we want to upgrade the firmware in the VIMs. First thing what we do is that move all the spares to the VCM that's going to upgrade the VIMs, because we need one spare VIM for keeping track of the delta writes, and the other spare VIM is needed for in case of any failure during upgrade. We take one VIM out of service, upgrade one at a time, but two VCMs can do in parallel. So technically 2 VIMs get upgraded in parallel. So we continue to do that for the entire RAID group in the single VCM. Once we are done, move the spare to the other 2 VCMs and continue the same process. At one point, all the components in the system is fully upgraded.
And one question, what happens if a VIM fails?
Yeah, if a VIM fails, there is a spare VIM always available. So the data services, your data is completely protected, RAID is completely protected, the NDU stops. The non-disruptive upgrade stops, you fix the problem, then resume the non-disruptive upgrade.
Okay. And how long this process takes to complete?
Okay, so
on a single module?
Yeah, so it's not about the single module, how long it takes for the entire system to upgrade. It happens in 2 hours and 30 minutes.
2 hours and 30 minutes.
Yeah, end-to-end upgrade.
Does it detect if there's any potential issues? So occasionally, it's rare, but sometimes you might have an issue with firmware, or you might hit a corner case. Is it able to detect that and then roll back?
Yes. So in a Violin memory system, the upgrade and rollback is the same thing.
Okay.
So the previous version is kept in the system.
Yep.
You can always roll back to the old one.
Okay.
I guess you're also
There are 2 partitions.
I guess you're also asking, is there a pre-check? Is there
Yes.
a hardware pre-check that says I've gone through everything and got all the
Correct.
green lights to say everything's okay to upgrade? I guess
Yeah,
that's
it's just
part
a
of-
checkpoint upgrade.
Yes.
That you've gone, yes,
So
it's good.
When you type, there is a command to check the health of the system before you do the upgrade. Even if everything is okay, but before you do the upgrade, if there's a failure in between, still we catch that. Yeah, pre-check is there. And complete scrubbing, for example, if you newly installed system, if you want to upgrade, until the full scrubbing is done, we don't allow you to upgrade.
Okay.
Yeah. So the management gateway, very simple. All the data services are moved from one management gateway to the another one, and the non-functional management gateway gets upgraded. Same process repeated for the other gateway. At one point, both the gateways are upgraded. Okay, supportability features. Let me quickly go over that. We have online and offline call home features, and we do predictive analytics of the log upload that happens every night, and we proactively inform the customer and replace the modules before it fails. Also, we have several auto recovery features in case of a RAID control module failure or a Vim failure. We recover many of the software failures on the spot. So customer doesn't even notice that. So that reduces our total number of support calls, and we can manage the system better.
Go on.
May I know what you mean by offline call home?
Yeah, so we get everyday nightly log upload into our support server, and we process the logs and look for potential errors that might happen in the future.
So with all of these features, and correct me if I'm wrong, this is all based on monitoring the hardware from a health perspective and spotting faults and proactively fixing them.
Correct.
Are you doing anything to actually look at the data and say, actually we could tune things better, or the next time we release one of these, the firmware could be upgraded so that it works slightly differently, and effectively getting analytics from the traffic rather than purely the actual hardware?
Yeah, I think that would be the next step. You want to answer that, Saeed?
Yeah, I can. I mean, so we do get actually statistics on the array, not only on the hardware, but also on, IOPS, latency, writes. I mean, a lot of data, and we do proactively reach out to customers sometimes, say, hey, we may want to reconfigure this, or may adjust that. So there is an analytics engine on the back, and it's being enhanced as we continue. And in the future, we'll also expose that information to customers through a portal. They can log in and actually see their arrays and how that perform and how they perform against the rest of the install base. So that's kind of our next step.
Because that's the key bit, isn't it?
Yes.
It's great to do one person in isolation, but when you've got hundreds of boxes, and you can aggregate that data and produce something more valuable.
Yeah. So we have thousands of arrays sending data every day, and then based on that, we can actually tell you, for that profile, how you're performing, how is your LUN doing. Yeah.
Okay, this is my last slide. Violin is a member of OpenStack from 2013. We started working on our first release, Havana, that is supported in our 6000 platform. And for the FSP, we are supporting iSource, Juno, Kilo, Liberty, and Mitaka, and we continue to support all the future releases. And it is Red Hat certified.
Question on the VIMs, are they hot swappable?
Is it swappable?
If a VIM fails, for example, can that be swapped online? Is it a hot swappable item?
All the modules are completely field upgradable when the system is running.
Right, it's
and hot swappable.
fully,
Yes.
it's a fully, it should be on. I turned it on. Yeah.
Okay, great.
It's the box is a fully HA hot swappable, right? Every active component is hot serviceable.